Okay, well, I'd like to personally introduce Rene Paap. Rene and I met for the first time face-to-face here. However, he was my first guinea pig for the IPv6 podcast. So I guess I'm plugging my podcast now. If you go to iTunes and you search for IPv6 podcast, I've done 3 so far. I've got another 2 in the can. However, the reason I really wanted to introduce Rene is that he's from A10. And as you notice, A10 is right here, sponsored by A10. And I think, I just want to acknowledge A10 for actually sponsoring this event because they're the ones that are paying for most of us being here today. So, so with that, Rene, I'll leave it to you.
So thanks, Bruce. Like I said, or like Bruce said, I'd like to do an overview of A10 networks and our IPv6 solutions. Give you an overview of what we do right now and a little glimpse of what's coming up, new features. Slide it down. Oh, thank you. All right. So for the people that do not know A10 or do not know as well, because we have grown very fast in a very short time, do a quick overview of the company. So A10 was founded in 2004 by Li Chen, who also founded Foundry Networks and Centillion Networks before that. And we have grown very rapidly in the last year. We're close to 600 employees right now. And I think we doubled over the last 2 years or so. So it's going very fast. So ACOS is our operating system. That's the driving force of all our technologies. Is very efficient and allows us to scale very well with the hardware we use. And the Thunder series and AX series is the core of our product lines right now. We have a lot of very well-known companies that use our products and are very happy with that. In the service provider space, a lot of wireless carriers here in the US are currently using our products. In CGN, I'll go over that a little bit in a moment. And in Japan, we're doing extremely well. We're actually #1 in Japan right now in the ADC market. And a lot of providers there are using us for the server load balancing as well as IPv6 migration technologies. And here in the US, where the IPv6 issue is growing as well, especially with large carriers. So we're rolling out in a lot of data centers there as well. But also Web 2.0 companies, everybody will see some logos of companies they know and products that they use right now. And with that, we have customers, over 3,000 of them, and in 43 countries over the whole world. So like I said, application delivery controllers is the core of our business. However, IPv6 is a big part of that. And it's running on the same platform. It's running extremely well because we have boxes with lots of CPU power and a lot of memory, so it's lending itself very well for IPv6 migration technologies. But in terms of application delivery, that can be the first step for a lot of companies, enterprises to get their introduction into IPv6 because it's very easy to connect your load balancer to IPv6 and then in the back end, take your whole IPv4 infrastructure of your website and that way be quickly connected to the IPv6 internet, like that. So like I said, our platform is really very capable of dealing with IPv6 migration technologies and to do so at scale. So the Thunder series and AX series are very capable of running a lot of sessions simultaneously, up to 256 million concurrent sessions, depending what platform, obviously. And this is going very well for us. So Very quick on a little bit of overview of IPv6 and the adoption rate. I'm sure we've seen a lot of slides already throughout this conference, but the bottom line is it's coming and it's coming fast. And everybody start realizing they need to do something about it, because more and more people bringing devices that need connectivity or an IP address, right? And the fact of the matter is we're running out of the IPv4 address space. So especially with the proliferation of the connected devices and the BYOD, people bringing their own devices to work and expect to be connected right there. So in terms of adoption rate, 2012 already we had more adoption than the previous years combined. So the percentage numbers are not that high yet, but it's increasing very, very fast. And one of the first deployments that A10 did in terms of IPv6 is in Japan, entity Plala. They had a project, Hikari TV, which was a fiber to the home project where they streamed karaoke services and it's all IPv6 native, and they're using our services to load balance that all over IPv6 natively. So we're very proud of that to be. I mean, this was back in 2008, but yeah, we definitely like to be on the front end of the IPv6 migration right there. So another thing we're very proud of. So as you know, very well know, the IPv6 and IPv4 are incompatible with each other, and yeah, people really need something to make the two worlds connect to each other. And that's what we're playing in with the AX series and the Thunder series. So we have a lot of technologies that I will go into a little bit in a moment. So carrier-grade NAT or large-scale NAT for the immediate relief of the IPv4 address shortage. And then we have various tunneling protocols and translation protocols to make this happen. So when you look at IPv6 migration techniques, basically they all fit in three different buckets, right? So first of all, there's the dual stack where you don't really integrate anything. You leave it up to the end device to decide where they route their packets on. So it's really separate clouds there. And then you can encapsulate either IPv4 in an IPv6 core network or vice versa, IPv4 in 6. And then we have a whole plethora of translation techniques that we support to make the two communicate with each other, which they natively cannot do. So here's a little curve that shows some of the techniques that are available and what they do. So as I mentioned, should be the laser, the SLBPT or protocol translation. So this can be the first step for an enterprise to enter themselves into the IPv6 realm. Just taking an IPv6 address, put it on the load balancer, and this is a very quick way to be connected without any big efforts in your infrastructure on the back end that can all remain in IPv4. So the next one up is carrier-grade NAT. We had a panel discussion on this yesterday as the necessary evil, or whatever you want to call it. But fact of the matter remains that it's an excellent technology for immediate relief. It aims to be the most transparent NAT technology that's out there, because a lot of proprietary NAT technologies will break a lot of applications, and carrier-grade NAT is not just designed to do everything at large scale, but to do so in a very transparent way, right? So then 6RD is a tunneling protocol where you tunnel IPv6 over an IPv4 core. So this will allow your users to connect to the IPv6 internet without making big investments in your IPv6 core just yet. And then when we move up to NAT 6.4, so this is more where we treat IPv4 a little bit more as a legacy protocol. So this way, we tunnel IPv4 over an IPv6 core network and allow legacy devices that are only capable of doing IPv4 to make them connect, or actually to connect the IPv6 only address devices to the IPv4 content that's still out there. There's 95% of the internet is still on IPv4. And then DS Lite is the tunneling over an IPv6 core network. So really, the top of the curve is treating IPv4 as the legacy protocol. Where we hopefully can retire IPv4 very soon, right? So in that same curve, we got a couple of use cases. I talked about it a little bit already. SLBPT, very quick way to connect your website into the IPv6 realm. Carrier grade NAT to immediately relieve your IPv4 address shortage in the most transparent way that is possible in a NAT. And so 6RD, we had a customer actually that had a new supplier. They were IPv6 only, and their internal clients needed immediate access to the IPv4 mothership in Texas, actually, I believe it was. And later on, this supplier in Texas bought the supplier in Asia Pacific region, and they needed to have a tighter integration. So NAT64 was a great way to make the users in the APAC region connect to the v4 services that were based in Texas. And DS Lite being rolled out in multiple areas in carriers right now, where they upgrade their core services, but still we need the IPv4 connectivity, right? So DS Lite is a great way of making this happen and still remain that connectivity for legacy devices. So the next one on Enterprise ROI. I mean, the C-level people always want to know, what's it going to cost me? What's it going to cost me if I don't? And what's the ROI of IPv6? So that's extremely hard to put a dollar sign on it. We've heard comments yesterday, just wait long enough and they'll figure it out by themselves, right? But there are arguments to be made why we need to transition into IPv6. So one of them can be a competitive element where you have your marketing team can boast about being on the front end of new technologies. Definitely a big driver. We've seen a lot of ISPs that we serve in Europe that are doing this, and definitely standing out from the crowd right there, from the old sluggish big providers that are out there. And the sooner you do it, the easier it will be, right? I mean, you have time to train your staff. You don't have any panic upgrades, and which can be very costly as well. But then more importantly, it's about being connected to the entire internet. I mean, when you go to a website, this is our old A10 website. When you go there, you expect it to show up. When IPv6 users want to go to this website, which is v4 only, then you don't want this, your number one brand. I mean, this is still happening. A lot of big brand names that are outside of the tech industry have nothing on IPv6. So this is definitely a concern for them. And this is a very good argument to lay in front of the C-level people. So SLBPT, this is an example of our own website, as a matter of fact, where our ISP was not able to provide us with any IPv6 addresses, and our DNS provider at the time didn't provide Quad A records either. So one of our SEs in Holland actually is running a data center. He said, well, I have lots of IP addresses, IPv6 addresses, so why don't we eat our own dog food? We will front end an AX series with an IPv6 address, and in the back end, it will load balance to the IPv4 only address. And it worked great. And we're running it still, as a matter of fact. It's going really, really well with a minimal effort. We had this all running in literally 5 minutes. It was really amazing. Next up, I want to talk about an example in the education sector. This is, I think it goes for a lot of enterprises as well, but this was here right in the US, where universities typically were a lot of IPv4 addresses, but they are feeling the squeeze as well. They get their students coming in on campuses, and they bring an iPad, iPhone, and an Xbox, and what have you. So there's a proliferation of connectivity that they need to maintain, and they were having big problems with it. So CGN provided immediate relief right there to take care of that, and they were able to host their staff and student applications over carrier-grade NAT without any issues. All their applications were still running smoothly. So it's a great first step. And very similarly, one of the top wireless carriers here in the US did not have a lot of IPv4 addresses, and they still want to expand. They still want to connect those cell phones, right? So they currently are running in more than 25 data centers in the US, are running carrier-grade NAT solutions over our AX series, and do so very well. So basically, they were able to reclaim 90% of their IPv4 address space, and had huge savings when compared to other vendors that do this in very big routers only with application blades. We do all this in one rack unit box, and very cost effectively, and I'll have more on that later. But also, this carrier knew that carrier-grade NAT is just a gateway, right? I mean, they know more needs to happen. This is not the answer. So they actually did a pilot with IPv6 only cell phones, and I think they had about 3,000 of them, and they used NAT64 translation to still maintain connectivity for these users that are on IPv6 only connection and still want to go out to IPv4 content, which again is like 95% of the internet still. And this was very successful, actually. So it was a very great way for them to alleviate their immediate need and slowly move into new technologies and slowly migrate into IPv6 right there. So last year with Network World, Scott Hogue did a test of the load balancers, and we did very well there in IPv6. Mentioned there, so we were the only vendor to receive top marks in this IPv6 part of the test, and with 5 out of 5 stars. So we're very happy with that one, obviously. But similarly, in Interop in Tokyo last year, we drove the network that drives the whole Interop network. We were part of that at the core to provide all these technologies running simultaneously with carrier-grade NAT, and translations was live being demonstrated and at a very large scale without any issues. So people there were able to connect to the Wi-Fi and connect to the whole internet using any technology we wanted. And we won awards for that, which we're very proud of. So let's get in a little bit more detail on our technology, on the hardware, which separates us from our competitors because we have very efficient form factor. So this is the AX3530, one of our flagship models for IPv6. And as you can see, it's a very compact form factor, one rack unit, and we were able to do 256 million concurrent sessions over this box. And the reason we can do that is we have very powerful CPUs, octa cores, and a lot of memory that you need to maintain all these huge tables for doing all this address translation. So the platform lends itself very well for this kind of work. And in other models, we also have silicon, FPGA silicon, for doing more powerful network tasks right there. So we have 10 gig ports. Other models, we have 40 gig ports coming up, and so it's very reliable. We have no moving parts in the front end of the box, so only on the back end we have hot smart fans and the power supplies. They can be replaced while the service is in unit is in service, and so on the front end you don't have to open up the box. So it's extremely reliable. And also with the hard drive, we stopped using regular spinning hard drive media a while back, and our RMA rates have dropped immensely because of this. So it's faster and much more reliable. It's working out very well. And so with that, the advantages over platforms, I think, is very much on our performance, very cost effectively, and in a very compact form factor. 1 RU for most of them, the really big boxes for 3 rack units for the real big carriers out there. But still, this is a very big difference from our competitors that only can do this in big routers that fill up a whole rack. And if you want full hardware redundancy, you need another one of those router filling up a whole rack. So it's a big contrast. So in terms of data center footprint, and in terms of the cooling and everything else that comes along with it. So it keeps adding up. It's kind of a summary overview of the requirements that you should look for when you look for a solution for IPv6 migration. So interplay is what we mean, that all these technologies like carrier-grade NAT and NAT 6.4, et cetera, they can run concurrently. So you can phase in your migration to IPv6, and that the users that are on these different clouds can still communicate with each other, which is something that is actually quite a challenge for a lot of competitors. The failover, you definitely, especially as a carrier, you do not want your current sessions to drop if you need to provide maintenance on one box, for example, or if something were to go wrong, power outages, what have you. We have hot failover, so all sessions will continue on the other standby box, and users don't even know that something went wrong. So that's extremely important. And then through CGN or LSN capabilities, with that, I mentioned it yesterday on the panel, some vendors say we can do NAT and we can do it very fast, so it's large-scale NAT. This is really not the case, because the strength of carrier-grade NAT is in its standardization, and it's aimed for transparency, and it's got a lot of features that the traditional firewall-based NATs do not offer, such as hairpinning, for example, so that the traffic from user 1 to user 2 will loop back into the network. And almost most importantly of all, especially with all these translation technologies, is the logging. I mean, you're going to have tremendous amounts of logs when you connect users and keep the translation, and you need to keep track of them for the lawful intercept, etc. If somebody needs to track down a user who had an IP at what time, you are mandated by government to keep these logs. So we provide a lot of options to reduce these number of logs, and also to get rid of them altogether with deterministic NAT. I've got more on that in a moment. So this is something you should not underestimate, because it is huge amounts of logs that you have to deal with and that you have to store for a long time. And your box needs to be able to produce these amount of logs without impacting the regular performance of your NAT functions as well. So this is really a big challenge for vendors to do. Then new features, of course, IPv6 is still new, and still new technologies keep popping up, and you need a vendor that can jump on them very quickly and implement them very quickly, because newer and better technologies keep coming up, and not two networks are the same. There's not one answer that is the best one. Every network is different, and every technology that's out there can be a better fit. So you definitely want a vendor that can play is very nimble and able to adapt. So data center efficiency, I talked about that, very obvious, important in terms of cost, budget friendly, but also in terms of the amount of data center footprint and the cooling that comes with it. With that, I want to give a quick overview of some new features that we recently introduced in the last year. So first of all, there's FixNAT. So FixNAT does via an algorithm. It knows about the tables of public IPs and the inside IPs, and it uses an algorithm, so you don't need to log each transition that's going on, because at a given moment, when you know the outside IP and port number of a certain flow, you can always trace it back to an internal IP. So this hugely reduces the amount of logs that it produces. It's only one line. So this is very favorable for a lot of people. Then we have lightweight 4/6. It's an enhancement on the DS Lite. Basically, it takes the whole NATing responsibility away from the after point to the before point, or to the CPE, if you will. So the NAT is happening there, and it's bringing a lot of relief to your endpoint, so you have less choke points in your network, if you will. We introduced L3V support, so we can do multi-tenancy. If you have different routing domains with overlapping IP addresses, for example, or you want to provide this as a service to different users. So we could think about SDN. In this case, we have support for that. We can run up to 128 virtual routing domains on one box. Stateful firewall we implemented, and a RESTful API to control it. So this is especially interesting for people that want to use such kind of functions in SDN environments, and have an API to control the box with. And something that's coming up very soon in early next year is port control protocol. So this is a technique where the CPE device can communicate with the translation point and have a defined set of ports, so it can run certain services on the CPE side. So you have a predictable port number on the outside that the rest of the internet can communicate with. And MAP-E, we're going to implement MAP-E again, well, similarly to lightweight 4/6, it takes the responsibility of the translation down to the CPE, and some more enhancements right there. And we got some more logging enhancements, so more fields of the HTTP header from the client that can go in the logs, which helps you trace back to the point of origin and do more smart things with it. And DDoS protection. So this is another big one that we will learn about more in this conference as well. But yeah, IP anomalies, DDoS threats are out there. They're very real, and more people have to deal with those. So we're implementing more features to prevent that as well. So as a summary, so what customers should do, we think, to make this move to IPv6 is to test your applications on all these technologies, make sure it works, make sure that you have the right application layer gateways that can deal with the layer 7 part of your transmission and translate that, so make sure that the application stays functional. And train your staff, so you have the time to train your staff on dealing with all these technologies and implement them. And start small. I mean, you can just connect your website to the internet, or do carrier grade net as a first step, and then phase in pilots for NAT 6.4 or whatever makes the most sense in your environment, and run a pilot with that and do all these tests again. And if you do it ahead of time, you'll save a lot of headache in the future when it's close to too late. And that ends my presentation.